All right, we're back with another Ohio State Test Standard Review video. Today we are talking about Standard 8.F.4, another continuation into our functions unit. So let's get right in. A convenience store has 20 bottles of water. Each day a supplier delivers the same number of bottles to the store. The store does not sell any bottle of water for 3 days and now has 110 bottles. What is the rate of change? So, there's a lot of information in here, okay? So, it starts with 20 bottles of water, okay? So, we're going to set this up as a linear equation. Y equals mx plus b, where m is our slope or our rate of change, and b is our y-intercept or starting value. Okay? We're starting with 20. And we know that after 3 days, we have 110. So now normally what you could do, there's a variety of ways you could do this problem. One way I like to approach this is I know that after 3 days I'm going to be at 110. We don't know the m, and we know that x, which represents our number of days, is 3. So now instead of writing and solving for x, we're instead just going to solve directly for m. Because m times 3 is 3m. Now we solve it like we solve any regular equation. So we subtract 20 from each side. That cancels out. 110 minus 20 is 90 equals 3m. And then you divide both sides by 3, and you get m equals 30. So it is 30 bottles of water per day. And I showed you how to do that a little bit differently because I imagine that most of the other ones, right, we're going to solve the usual way of finding slope. So we'll do something a little bit fun. All right. A conversion chart between a number of quarts and a number of liters is shown. Compare the equation to model L in terms of Q, meaning that Q will be X, L will be Y. All right. So, we're going to compare our rates. So here's how we're going to do this. In case you haven't seen the other function videos, here's a quick refresher. Slope is equal to our difference in y over our difference in x, our change in y over our change in x, or as we wrote it, y2 minus y1 over x2 minus x1. The moral of the story is you're going to find how much your y is changing. So to go from 0.95 to 1.90, you subtract 1.9 minus 0.95, and you get 0.95. Then you subtract 2 and 1. 2 minus 1 is positive 1. Okay? And then you take your change in y, which is 0.95, and you put it over your change in x, which is 1, and you divide anything over 1 is itself, so you get 0.95. And we're going to write this as 0.95 q. And then we would have to find our y-intercept, our starting value. You can kind of infer it from what this problem is telling you, because if you have no quarts, that means your cup is empty. Therefore, you wouldn't have any liters either. But just for fun, let's remember what a slope represents. For every 1 that x goes up, y goes up 0.95. And vice versa, by which I mean for every 1 that x goes down, y goes down 0.95. So if we want to get to our x of 0, which is how you find the y-intercept, is where x equals 0, then we have to subtract 1 from this chord, which will bring us to 0. And for every 1 that x goes down, y goes down 0.95. So 0.95 minus 0.95 would be 0. So your y-intercept is 0. You do not have to put plus 0. You could leave it like this. Now, important thing to mention. We use x and y for most variables. Okay? However, in this question, they use L and they use Q. And they tell you to model L in terms of Q. And they give you L equals. What that means is that this cannot be 0.95x. That is wrong. It has to be 0.95q. If they give you a variable, you have to use that variable. You cannot change the variable. All right. The graph of a linear function passes through the two given points on the coordinate plane. 3, 15, 6, 21. What is the rate of change? Rate of change, same thing. Slope, y2 minus y1 over x2 minus x1. Double checking. Did I go over that this video? I sure did. All right. I apologize. I'm recording these in bulk, so I have to remember what I went over and what I haven't. All right. So we're going to label our points. Our top point's going to be x1, y1. Our bottom point's going to be x2, y2. Okay? And we're just going to fill in the formula. y2 is 21 minus y1, which is 15, over x2, which is 6, minus x1, which is 3. 21 minus 15 would be 6. 6 minus 3 would be 3. 6 divided by 3 would be 2. So your rate of change is 2. That's it. Just 2. Darren and his friends save money for a vacation. Darren starts with $120 in savings. Every week, Darren adds $40 to his savings. Darren's friend also begins with $120 in savings, but saves at a faster rate than Darren. Okay, so let's talk about the equation first. Y equals mx plus b. Right? For Darren, he starts with $120. It says starts with. So that means if we have y equals, our starting value is b. Every week, each is one of your keywords for slope, each week, Darren adds $40 to his savings. So 40 represents our M, our rate of change. So you're going to plug in 40. Darren's friend also begins with $120 in savings, but saves at a faster rate than Darren. So we're going to put friend, y equals, he's starting with 120. Create an equation that could represent the amount of money, y, in dollars that Darren's friend saves for vacation after X weeks. Okay? The only thing you have to do is you have to keep the y equals 120. Okay? That's the equation that we found with Darren. That's the equation we started with the friend. The only thing that determines whether or not this is the right or wrong answer is your coefficient for x bigger than 40? 41? Good. 56? Good. $40.01? Good. Don't reinvent the wheel. Use something simple. Go 45. 45. That's it. Your coefficient for x, your slope, just has to be bigger than Darren's slope, and that's it. Everything else stays the same. Complete the table to create a linear function. Okay, so here's how how I would do this. First off, we're at 0 for x, and I'm going to start us at 0. You could start your y anywhere, but like I've always said, I like working with 0. 0 is an easy number to work with. So after that, you have to figure out what you want your rate of change to be. Okay? Your rate of change could be as easy as 1. Okay? For every 1 that x goes up, y goes up 1. So here, x goes from 0 to 2. It goes up 2. So y should go up 2. Here, x goes from 2 to 5. That goes up 3. So y should go up 3. That's it. That's a linear function. You just need to have a consistent slope. Actually, even if they give you this exact question, you could just put these exact numbers, 0 to 5. It has nothing to do with slope. Because if it's the consistency between here, then it's a consistency on the y side also. So if they give you this question, complete this table to create a linear function. Complete this table to create a linear function. And they give you x, and they ask you for y. Just copy over x into y. That's it. That function, for what it's worth, y equals x. That's a linear function. It looks like, nope. It looks like that. That's it. Some values for two linear functions a and b are shown. So we have function a, we have function b. Function c is a linear function with the given characteristics. The y-intercept of c is between the y-intercepts of a and b. The rate of change of c is greater than the rate of change for a and less than the rate of change for b. Use the add arrow tool to draw a possible graph for function c. This is a very involved question. So we have to approach this 3 ways. Step 1, we have to write an equation for the first 2 functions. So to do that, we need a slope and a y-intercept. They don't give us x equals 0 for either of these functions, so we're going to have to do this the hard way. We're going to find the slope first. How do you go from 12 to 20? 20 minus 12, you add 8. To go from 3 to 7, 7 minus 3, you add 4. Then, to find your slope, you do your change in y over your change in x. 8 divided by 4. That's 2. So that's going to be 2x. So what that means is that for every one that x goes up, y goes up 2, and vice versa. For every one that x goes down, y goes down 2. Okay? So x goes up 1, then y goes up 2. If x goes down 1, then y goes down 2. So we have to recreate what the y-intercept would be. Remember, y-intercept is where x equals 0. So we have 312, and we want to get to 0. So we're going to go down 1. We're going to minus 1. That's going to bring us to 2. We're going to go down 2 on the y. That's 10. Go down another 1. And go down another 2. So that would be 1, 8. Go down another 1. That brings you to 0. Go down another 2. That brings you to 6. So 0, 6 is your y-intercept. So you go with 6, plus 6. All right, we go to our next problem, our next function. Our slope, 2 minus negative 1 would be positive 3. 10.5 minus 1.5. Even I'm going to double check my math on this one. And y'all know me, I pride myself on my mental math skills. But, okay, that is 12. So we find our slope. 12 divided by 3. That gives us a slope of 4. Meaning that for every time x goes up 1, y goes up 4. And for every time x goes down 1, y goes down 4. So we need to recreate the y-intercept. Okay? So let's start at -1, comma, -1.5. To get to 0, we have to add 1. So we're going to add 1, which means here we're going to add 4. -1 plus 1 is 0. And -1.5 plus 4 would be 2.5. So our y-intercept is 2.5. So we found our two equations. Okay? These are our two equations. So the y-intercept of C is between the y-intercepts of A and B. So it has to be between 2.5 and 6. Let's put it at 3. Why? Because we can. Okay? The rate of change is greater than the rate of change for A and less than the rate of change for B. The rate of change for A is 2. The rate of change for B is 4. The easiest way to go less than 2 or greater than 2 and less than 4 is to go to 3. So our new equation will just be y equals 3x plus 3. So now let's talk about how you move with a slope if you're actually drawing a graph. Okay? If your slope is 3, first off, to make your slope movable on the graph, you want to make it a fraction. To make a whole number over a fraction, you put it over 1. So your numerator determines whether you go up or down. If it's positive, you go up. If it's negative, you go down. Your denominator, you'll be going right because your denominator will always be positive. Okay? So, positive 3, 1, 3 over 1 means we're going to go up 3, right 1. So we're going to take our point that we started our y-intercept. We're going to go 1, 2, 3 up and right 1. 1, 2, 3 up, right 1. And I don't exactly know how the add arrow tool works, but your arrow should look something like this. And that'll be that. So find your slope, find your y-intercepts, and then just follow the directions. So, like I said, I know that is a tricky, complex question, but there's no way around that, short of hoping that's not on the test. So, that's going to do it for this standard. I'll be back with more standards. Until then, good luck on your state test.